Hello everyone, this is the presentation of Mechanism Sessional Group project for which we have decided to synthesize and simulate the windscreen wiper mechanism without quick run effect. Our team members are myself Rohit Kami 21ME10062, Sahil Singh 21ME10066, Pushkar Jagtap 21MF3IM12. The problem statement that we have chosen is to synthesize and make a simulator for the windscreen wiper mechanism with no quick run effect. We have ensured that our mechanism satisfies Grashof criterion. The quick run effect occurs when forward speed and return speed are different in crank mechanism. We have ensured that there is no quick run effect occurs in our mechanism. Software that we have used are MotionGen and MATLAB. We used MotionGen for simulation and wiper building. We also use it to plot graphs for links and joints of our choice, such as angular displacement versus time graph, angular velocity versus time graph, and angular acceleration versus time graph. We used MATLAB for computation of our link lengths and necessary angles. We also plotted virtual wiper mechanism and also went through other necessary aspects such as area swept and total angle through which it moves. Now Sahil will take you through the MATLAB computation and simulation.
So now we'll go through the MATLAB computation and simulation part of this project. So here we have taken arbitrary lengths of L1 and L4 and L1, and MATLAB arbitrarily set the rocking angle to pi by 3. And using these values, we have calculated remaining lengths, that is L2 and L3. We have calculated L2 using the rocking angle equals 2 times r sine L2 by L4. We have got L2 from here, and we have got L3 from this Pythagoras theorem, that is L1 squared plus L2 squared equals L3 squared plus L4 squared. They are the values that we have got. Next, we calculated theta 4 that is the angle at which L4 locks. And then we have created an array of theta 2 values from 0 to 5 pi by 2 to pi by 5 till in an interval of 5 pi by 180. Next, we calculated all the values for theta 4, positive as well as negative, corresponding to the values of theta 2. We have ran one loop for that, and we have used 3 intermediary variables and some formulas that has been stated here. Similarly, we calculated the values for theta 5 and for theta 3. And next, we went to calculate the start vibe degree and end vibe degree. And basically, here we can see 60 degrees from the center is the total angle swept on one side. So basically, it is around 120 degrees, seeing both the sides. And theta 5 subtracts as much 60 minus start vibe degree to give an angle between L4 and L5. So here we have got an angle between L4 and L5. So now we are getting theta 5 given theta 2. So here we have again used a similar approach. And here we have printed some values that we require that we'll see in a minute. Here we have all these coordinates that we require to plot the graph that we'll see in a minute again. And here we are plotting that. And we are also plotting the area that is being swept by the wiper at every instant over this loop over theta 2. And we have plotted that graph. And next, let's see this virtual simulation of that. So here, as we can see, this is the total area that the wiper swept at every instant. And all these are the links. This 04, 05 is the link which is named L1, and this rotatory link is L2, and the link between them is L3, and so on. So this is the wiper, and next, Pushkaraj will take you through the MotionGen simulation, which is much more detailed than this.
So we are using MotionGen as our simulator to simulate our windshield wiper. We will check whether our model has quick return effect or not. We will also plot the graph of displacement angular velocity and acceleration of a joint and a link to get insight of the analysis of motion of our model. So from our findings from our MATLAB code, this is our model. The dimensions are also taken from MATLAB. We have added a rotatory actuator at this joint, which gives a constant omega input. So we will run this model. So we can see in this simulation that there is no quick return effect, and our model also satisfies Grashof criteria. Moving to the analysis of the motion of our model, MotionGen has a feature which allows directly to show us the displacement, angular velocity, and acceleration analysis through graph. So link graph. I will just select any link. So let's take our input link. So this is our, so MotionGen has plotted the graph of angular velocity, angular acceleration, and theta versus time graph for us. So let's start the simulation. We can see here that as we said earlier, angular velocity is constant, which is around 1 radian per second, and angular acceleration is 0. Now we will see analysis of our output link. So this is our output link. See, here angular acceleration is not 0. Our output link is connected to our wiper. We can also see its analysis. So this is our analysis of a wiper blade. It's almost straight line. It's not straight, but it's almost straight. We can also do the analysis of a particular joint present in our model. So like, let's consider this joint, which is connected to our output link. Okay, so we can also build this our model and 3D.